In this clip, we're going to define a rational function and look at some examples of what a rational function is and is not, and why. So basically, a rational function is a polynomial divided by a polynomial. That's essentially what this is saying. Let p of x and q of x be polynomials with q of x not equal to 0. Then the rational function is given by r of x equal to p of x over q of x. Okay. Now, polynomial functions. Most of you are very familiar with polynomial functions already. So for instance, a linear function is a polynomial function of degree 1, right? That's the highest exponent that we see. A quadratic is a polynomial function of degree 2. You can have a polynomial of degree 3, 4, 5, etc. So we're going to take a look at some examples of that and kind of get a feel for what a polynomial is not as well. I've got a list of various functions here, and our task will be to determine if the function is a rational function, and if it's not, discuss why. So in this first example, we have f of x equal to x plus 4 divided by x cubed minus x squared plus 1. Both the numerator is a polynomial as well as the denominator. So I'm going to say yes, it is a rational function, right? Because we have a polynomial divided by a polynomial. Okay, now in the case of g of x equal to the absolute value of x plus 1 over 2x, this is not a polynomial. Anytime you have variables inside an absolute value, that isn't going to obey the definition of a polynomial function. And the graph of that has a sharp corner. All polynomial functions are smooth curves. And the reasoning would be, I would say absolute value functions are not polynomials. Okay. So then this next one, h of x is equal to 3 over x squared minus 1. Both of those are polynomials, both the numerator and the denominator. Now, some people look at that numerator and they say, well, 3, I mean, that's not, you don't even have a variable involved there. You could technically call this the zero polynomial, right? You could say 3 times x to the 0. X to the 0 has a value of 1. So that's one way that you could look at that. But even if you had h of x equal to 7, that's a polynomial function, right? So as long as you have a polynomial divided by a polynomial, this is a rational function. So now with k of x equal to 6 minus x over the square root of x plus 1, no, this is not a polynomial. And the reason is the numerator is a polynomial function, but the denominator has a square root. In order for it to be a polynomial function, all of the exponents have to be positive integers. And in this case, we don't have that. So I would say root functions are not polynomials. In contrast, if we have m of x equals to the square root of 5 times x squared plus 1 all over x, that is a polynomial function because even though you have the square root there, there's not a variable under the root. The x squared is outside of the root. And so that square root 5 is really just a coefficient on x squared. And the coefficients can be any real number. They don't have to be integers. So this is a polynomial. And now this last one, p of x is equal to 5 minus x to the negative 3 all over x to the 0.9 plus 2x minus 1? No. The reasoning that I would get, in order to have a polynomial function, in this case the numerator nor the denominator is a polynomial function because the exponents have to be positive integers. And in the numerator we have a negative exponent, and in the denominator we have the 0.9 there, which is not an integer. And I think I'll just say that exponents must be positive integers to be polynomials. So hopefully you're getting a feel for this, what a rational function is. It's a polynomial divided by a polynomial. If the numerator and or denominator don't meet that criteria, then it's not a rational function.